Station, this is Houston. Are you ready for the event?
Houston Station, I'm ready for the event.
Burt Church High School, this is Mission Control Houston. Please call station for a voice check.
Station, this is Bonnie Schmidt from Let's Talk Science with students here at Burt Church High School. How do you hear me?
Well, hello, Birch Church High School and the folks at Let's Talk Science. I read you loud and clear. Greetings and welcome aboard the International Space Station.
Hi, Chris. It's Bob Thirsk here. There's 1,000 students, teachers, parents, and other officials here. I'll turn you over to our first student who has a question.
I'm Oscar, and my question is, what did you have to do to adjust to living in space?
When you first get here, it is so weird. Your body is so confused. Without gravity, all sorts of things change, and you feel sick, you feel congested. It feels like you're recovering from an illness or something. So it takes a while just for your body to adapt. But then once your body adapts, then the other thing that you need to do to adjust is just start to get elegant in weightlessness, how to move and fly around without bumping into things and knocking stuff off the walls and crashing into things. And I found that my body recovered in 3 or 4 days and felt pretty good. But to become elegant and graceful in space took about a month. But now I feel completely adapted and adjusted, and it's going to be hard to go home.
I'm Gavin, and my question is, since you're in space for 5 months, are you worried about how your body will react to neutron radiation exposure?
Yes, as you well know, our sun and every star in the universe is a huge nuclear furnace pouring out radiation. It's what keeps us alive, the heat and the energy from our sun. But without our atmosphere and the Earth's magnetic field to protect us, the radiation is much higher. And here on the space station, we still have the magnetic field, but we don't have the atmosphere. And so we're interested in it. And my body, of course, stops radiation. And when the radiation hits my body, it can do damage at the cellular level. We're doing an experiment here on board, just as you folks are with Let's Talk Science, with a small detector. And with that, we can try and track the radiation damage, or at least dosage in our bodies. But I, of course, was worried about it before flight. I talked to our radiation experts and our scientists, and we don't want to risk the lives any more than we have to of the people that are exploring space. And there's a slightly increased level of radiation exposure, but it's not that far different than people who work in the industry, people who work around X-ray machines, pilots who fly at high altitude, or even someone who chooses to live their whole life at a high altitude in La Paz or even in Denver or somewhere that's a mile high.
Hi, my name's Caitlin, and my question is, if humans were to live on Mars, would they be more exposed to radiation than we are here on Earth?
Caitlin, yes. Mars, we're just learning about Mars, of course, with rovers on the surface and some of the spaceships that are orbiting Mars, coming from countries all around the world. Canadian hardware is on the surface of Mars right now. But what we found is Mars has some weak magnetic field, but not very much, so it doesn't protect the planet very much that way. And it has an atmosphere, but not a very thick atmosphere, and not a lot of water vapor. And so it doesn't soak up much radiation. It protects you better than empty space, than the gap in between Mars and the Earth, but it's not like being home, not like Mother Earth. So when we do go to Mars, and hopefully you'll be one of the people standing on Mars, you will need to have brought with you radiation protection. It's not that hard to do. We know how to do it. You just have to plan for it.
Hi, I'm Taylor, and I would like to know, what is it like to operate the Canadarm 2?
Operating Canadarm 2 is so much fun. In fact, you can operate it from right here. You have two hand controllers or joysticks, and you turn it with your right hand, and you move it up and down and back and forth with your left hand. So moving like a big, elegant version of your arm, except instead of your arm, it's got a hand at both ends. So it's got two wrists and an elbow. So you can really move the Canadarm much more than you could move your own arm. So you have to pay attention. You got to look at the screens, plan ahead. But the actual flying of Canadarm 2 is a real joy. And I got to fly Canadarm, the original one, on the shuttle. I've used the one here on the space station several times. And it's easy because of the training. It's intuitive, it's fun, but also it just makes me feel great as a Canadian to be operating Canadarm 2 on the International Space Station.
Hi, I'm Justina, and I would like to know what was the most challenging part of becoming an astronaut?
The most challenging part of becoming an astronaut, I swear, is getting selected. Canada has only chosen a small handful of astronauts in our whole history as a nation. And the selection process is so rigorous and so demanding that I was really nervous. And I know that Bob Thirsk, who's there with you, probably felt the same way when he was selected. In fact, Bob was part of the team that looked over the applicants to try and see if I'd be a good astronaut or not. So thank you, Bob. But that was the hardest part, was getting through that door. But then once you're an astronaut, then I think the hardest part is just remembering everything. People are trying to teach you important things for years and years and years, and you need to know them all to live and work here. And so I think the hardest part of being an astronaut is remembering all of the key information that'll let you be successful once you get to space.
Chris, it's Bob here. Just wanted to say we did a fine job selecting you as an astronaut. And I was just going to ask you if you can do a somersault for us. Show us what weightlessness is all about.
Well, being weightless is just so much fun. There's no up or down. It's completely arbitrary. You can choose completely which way you want to go. And Bob, you've been here and you know exactly what it's like. So you could just float and turn and tumble and do 1,000 somersaults. And you can do an interview with students in Airdrie, Alberta, sideways if you want.
Thank you.
I'm Miranda, and I'm just wondering, does the food taste the same in orbit as it does on Earth?
Miranda, at first, no. And it's not because of the food. It's because when you first get to space, gravity, of course, is not pushing the blood to your feet anymore, because you're basically weightless. So your body has learned over your whole lifetime to squeeze the blood up to your head so you don't faint. And that's kind of fighting, because normally your body has to work against gravity, and it doesn't recognize immediately there's no gravity. So your body keeps squeezing the blood up to your head, but no gravity to push it back down again. So your head sort of inflates like someone was squeezing the bottom of a balloon. And so your head fills up with fluid, and your sinuses fill up. And so when you first get to space, within a little while, you're all clogged up and sinus plugged up. So you can't even taste your food. And that lasts several days until your body finally gets to equilibrium. And then the food tastes about the same. And I have Canadian food right here that folks were nice enough to send up to me, which just came up on the Dragon spaceship recently. But I have a lot of nice food. I have Canadian maple cookies. I have smoked salmon pate, some Canadian chocolate. Look at this, a tube of maple syrup, which is a real treat up here. Really high quality maple syrup. And from not too far away from you guys from Saskatchewan, I have some buffalo jerky right here. Cranberry flavored buffalo jerky. And we even have something from the East Coast here with blueberry granola bar. So we have lots of food. It keeps us healthy. It tastes good. And it's a really important social time of the day when you can get together, talk about what everybody's doing, and relax and really try and share the human part of being in space. Food's good up here.
Okay. Hi, I'm Karis, and I want to know how long does it take to travel to the International Space Station from Earth?
Karen, it took us 2 days, but it doesn't have to take that long. You launch out of a rocket pad, a launch pad in Baikonur, Kazakhstan. Bob and I have both done this, a Russian rocket called a Soyuz. And the space station is somewhere around the world, and you sort of play chase, a tail chase, and you have to get just to the right point so you can come up and dock. Well, you could do it quickly, but it's kind of nice to have a little time to adapt and check out all your equipment. But then again, you run a bit of a risk with your little spaceship of any moment it's not on the Earth or docked to the space station. If something breaks, then you run a risk. So this next space launch that's going to happen in about 3 weeks, they're actually going to launch and dock in 6 hours. So they'll be sitting. Just imagine if today, right now, you launched 6 hours from now. I mean, by supper time, you could be up and dock with the space station. So it can happen amazingly fast.
Hi, my name's Emily, and do you see satellites and the other planets through the window?
Emily, yes, we do, but not that much differently than on Earth. Of course, the other planets are millions of kilometers away, and we're only a few hundred kilometers away. So even the moon, although it's very slightly clearer and very, very slightly bigger, we're much, much closer to the Earth. So even the moon looks pretty much the same. The other planets, we're not far enough away from the Earth to have a significant difference. Stars look differently just because there's no air in the way, so they don't twinkle. They're not scintillating because of the atmosphere. So they're nice and clear. And other satellites, most of them are well above us. Most of the satellites, we're kind of in the minimum orbit that you would want to be. So you only see them as little points of light going by, and you only see them rarely. But any clear night in Alberta, if you go outside just around sunrise or just after sunset and wait, and you'll see satellites go over. Sometimes you can see this satellite go over, and that's what they look like to us also.
Okay, I'm Alexi, and what does a launch feel like, and how is the G-force?
Alexi, for launch, you're lying on your back. So you're sort of lying like this. Oop, it's hard to be stable. You're lying like this, and you're accelerating that way. So all of the force is on your body this way, squishing you down into your seat. And you know, you could build a rocket ship that could have a lot more acceleration than the human body could take. So it's kind of a trade-off. And we've decided about 4 or 5 times your body's weight, that's enough. That's pretty heavy on your face and your chest. It's hard to breathe. You're wearing a lot of safety equipment. And so your rocket ship is going that way super fast. You're getting squished into your seat. There's some vibration. You can feel the rocket sort of steering like a boat going through the waves as it's steering to get exactly to the right orbit. And it gets quite heavy. As you burn the fuel, the rocket, of course, gets lighter and lighter. So even though the engines are putting out the same amount of force, because you're getting lighter and lighter, then it feels a higher and higher acceleration. So you get squished more and more. F equals ma. By the end of it, you're getting pretty heavily squished into your chair. But it's a heck of a ride. It only takes... We've been talking for a little over 10 minutes. It takes less time than that to get to space. From the time the engine's light until you get to space is only about 9 minutes. And it's a rough ride, but boy, it is a ride I'd be happy to do again. And it's a ride that takes you someplace you can't get any other way, and it's a lot of fun.
Hi, I'm Ashley. Do you have a 45-minute day and then a 45-minute night every time you orbit?
Ashley, here, grab this gray tape. So let's say that this is the world, okay? This roll, I'll get a little closer, you can see. Let's say that this gray tape is the world. So we're going around the world, but if you guys are the sun, then sometimes we go around the world this way. And if that's the case, then you're right. You'd be in the sun for about 45 minutes, and then you'd be behind the world in the shade for about 45 minutes. But our orbit precesses, and sometimes we go around the world sort of this way. And if you're going around the world this way, then if you think about it, if you guys are the sun, then you might come into the sun right here, and you'd be in the sun almost your whole orbit until you came around to the shadow again, sort of following almost the sunset line on the world all the way around. And sometimes that happens where you're sort of at an oblique angle to the sun, and so you get a lot of sort of dim sunshine until you come around, and then you get a little bit of night on the other side. So the maximum you can ever get is your 45 of night, and then it gets less and less depending on your angle to the sun.
Hi, I'm Haley, and I was wondering, can you feel the speed of the ISS as it orbits Earth?
You can't feel the speed, Haley. It's sort of like, you know that in Alberta, you're going pretty fast. You know, you see the sunrise on one side in the morning and it goes across and sets on the other side in the evening, and that's because the world is turning. So you've got a lot of speed. You're moving fast, but you don't feel it because everything's moving along with you. And it's the same up here. The only time you really get a sense of the fact that you're moving is sort of like where you are when you look at something else. When you look at the sun, you can tell as the sun rises and goes to the sky that you know the world is turning. Well, for us, when we look down at the Earth, especially if you look straight down, we're going 8 kilometers a second. You know, you could be in Calgary in just a few seconds. And we right across Canada in 10 minutes from the Pacific to the Atlantic. So when you look straight down, it's amazing how fast the world goes by. And you actually, even though we're a long ways up, you get a ground rush just from the incredible speed. We go 28,000 kilometers an hour, almost 500 kilometers every minute. It's pretty blistering speed.
Hi, I'm Rachel, and I'd like to know, during the launch, how do you know when you've entered space in microgravity?
That's an interesting question. The purpose of the launch is, of course, number one, to get you above the air, because you can't go fast enough in the air. There's too much friction with the air. So first, the rocket has to get you above the air, and then it has to tip you over and get you going fast enough to stay in orbit. Because if you're not going fast enough, you'll just fall back down into the air again. But there's a certain speed that is just fast enough that you'll fall at the same rate that the Earth curves away from you, and so then you'll be weightless. Because you'll just keep falling, just like I'm falling right now. But because we're going fast enough, we never fall down into the atmosphere. The Earth's curvature matches our fall rate. So that speed is 8 kilometers a second. So when you're in your rocket ship, it's getting you above the air, and then it's accelerating like crazy, squishing you in your chair until it has calculated, the computers in the rocket ship have calculated that you are at exactly the right height, the right angle, and the right speed, and the engine shut off. And at that moment, you are in space and you are weightless, because you go from being squished in your chair by the acceleration of the rocket to suddenly weightless and floating inside your rocket ship. And it just happens. It's like you were getting pummeled and beaten up and squished by, some big fat gorilla sitting on you, and then they picked up and threw you off a cliff. And that's what it feels like.
Hi, Mr. Hadfield. I'm Ashton, and I was just wondering, how does it feel to sleep while you're floating in there? Yeah.
Ashton, how does it feel to sleep? Here's how you do it, okay? So you go. I have a little sleeping room just over there. When it's time on my watch to sleep, because of course the only way to tell is by time, because the sun's not right. So you go in, you float down into your sleeping bag, you put your feet into it, you float your whole body into your sleeping bag. And then the sleeping bag has armholes. So you put your arms through the armholes, you do up the great big zipper, and the sleeping bag has a couple little shoelaces tying it to the wall. And that's all. And then you just relax inside your sleeping bag. And when you relax, your knees, it's sort of like, if you ever seen a picture of a neonate, inside their mother's womb where the body's floating, It's sort of like that. Your knees come up, your arms float up, your head comes forward, and you relax. And every single muscle in your body is relaxed. Everyone. You don't have to roll over. You don't need a pillow. Your shoulder doesn't get sore. You don't get hot on one side and cold on the other. You are completely relaxed. So it's a wonderful way to sleep. You just, every joint is completely relaxed in your body. I love sleeping in weightlessness. You'd like it, Ashton.
Commander Hadfield, it's Bonnie Schmidt from Let's Talk Science again. We've just been notified that our downlink is ending, but I want to thank you so much for joining us with everybody here at Burt Church High School. You've made us so very proud, and your capacity to take millions of us on this incredible voyage with you will be remembered by all of us. So thank you, and good luck with the rest of your mission.
Thank you very much. Let me just say thank you very much. Thanks to all the students for the great questions. For the students that I didn't get a chance to answer your questions, I'll answer them in writing for you. And thank you to Let's Talk Science. That's a really good organization in Canada, doing a lot of good work right across the country. And we need to understand how things work to make Canada a viable, healthy economy. And Let's Talk Science really helps young Canadians learn and figure out and invent how things work. And so thanks for doing that. Thanks for having me into your school today. I wish everybody all the best. And signing off from the International Space Station, this is Chris Hadfield. Bye-bye.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you. Let's Talk Science participants. Station, we are now resuming operational audio communications.